Welcome to this problem session for vertical translation and phase shift. And as you can see, we're going to do a number of problems, total of apparently 9 categorized in 5 groups here. So the first one says, graph one complete cycle of each of the following. In each case, label the axis accurately and identify the amplitude, period, and vertical translation for each graph. So here we have y equals -2 plus 2 sine 4x. There's a vertical shift of 2 down. The amplitude is 2. The coefficient b is 4. And of course, because the period equals 2 pi over b, and b itself is 4. That's why we come up with pi over 2 for the period. So, and that's kind of what I said here, and then we're going to look at the range here. Of course, that's the range is the vertical shift plus minus the amplitude, and then we're going to look at the period and the scale. I guess pi over 6 is what the way I'm going to draw this on the graphing calculator. Okay, let's go over to a graphing calculator. Alright, so we have -2 plus, just want to get rid of all of this here and start over. -2 plus 2 sine 4x. I'm going to look at the window. It says 1 period, so I'm going to start from 0, and normally I would go to 2 pi, but that has been shortened to 2 pi over 4, which is pi over 2. So pi over 2. Scale of pi over 6. Could be something else. Could be pi over 4, pi over 8, or something. That doesn't matter too much. And the y minimum, well, as I said, it's going to be -2 plus -2. So I'm going to put this here at -5, and then I'm going to put this here at 1, so that the screen is just a little bit above and below the sine curve that we have here. And there it is, 1 full period. And the scale here is pi over 6. And 2 pi over 6, 3 pi over 6, that's exactly pi over 2. Okay, the other one, I might as well stay here in the graphing calculator. So the next one is going to say -1 plus 1/2 cosine 3x. So we have vertical shift of -1, an amplitude of 0.5, a coefficient b of 3, and then the period would come out to 2 pi over that 3. So in the width setting, I'm going to do a period of 2 pi over 3. I guess I keep this here at pi over 6. And then the range I'm going to have is -1 plus -0.5. So I'm just going to stay a little bit above the, above the x-axis. And below I'm going to have -1 minus 0.5, so maybe I'm going to put this here to -2. And there we go. So there's a cosine. And there it is. That's it. Just going to pause it for just a moment. Okay, here we're going to, it says, graph one complete cycle of each of the following. In each case, label the axis accurately and identify the phase shift for each graph. And not only will I do what is given in this problem as y equals sine x minus pi over 3, but I will do also the normal sine x so we can compare what happened to the curve. And while I'm on the graphing calculator, I might as well do the next one here as well, which says graph y equals cosine x minus pi over 2. And then again, I will just graph the normal cosine and see how that is affected in each case, how the graph is affected in each case. Okay. The phase shift here comes out to pi over 3 on the first one because the phase shift is defined as negative c over b, and because the c is pi over 3, I'm sorry, negative pi over 3, and the b, which is right in front of the x here, is simply 1, so we have negative pi over 3 divided by 1. So I'm going to grab this one here first, put it in there. So negative pi over 3 divided by 1, and that's why we come up with positive pi over 3. And then it's really similar for the other one. So, graphing calculator. Okay, on the first one, I'm just going to do a sine x first. Let's see, sine x. Amplitude is 1. There is no vertical shift, so I'm going to go in here and just go here from 0 to 2 pi. It's at 1 complete cycle anyway. I'll leave the scale at pi over 6. And here we're going to have, let's go between negative 2 and 2. Okay, and then I'm going to graph this one here. Actually, I will put the normal sine graph in bold. There we go. So there's the normal sine graph. And now I'm going to go in and do the other one, which is sine x minus pi over 3. And there it is, and as you can see, it's shifted to the right. So remember, when you have a minus in there in front of the coefficient c inside the sine, that actually means it's shifted to the right. The reason behind that is that it cancels with the negative from the phase shift formula. Okay, in the meantime, I inserted the equation here to show up on the screen so I can make a copy of it and paste it in the script. Let's do the other one, which is simply cosine of x. So there's the cosine in bold. And now we're going to do cosine x minus pi over 2. And there it is. And again, because it's a negative coefficient inside the cosine, that's why it's shifted to the right. Again, I'm going to put the equation in here. That is the normal cosine. This is the one I just graphed. So just like we saw it a moment ago on the graphing calculator, that's exactly what happened here with the phase shift. Okay, let's do the next problem. Where it says, again, graph 1 complete cycle of each of this equation, which is y equals cosine x plus pi over 3. And I'm going to do the same thing. I'm also going to graph y equals cosine x, and in contrast, I will also do this one here, y equals cosine x minus pi over 3 and cosine x itself. So let's go ahead. So just the cosine again in bold. And then perhaps because it's being shifted to the right, I'm sorry, to the left, I may want to start earlier here, maybe at negative pi. So I'm going to start at negative pi and then going to go all the way up to pi. Again, I will have just one period. So there's the cosine for this one. Remember I said it's going to be shifted to the left, the next one. So that's why I opened it on the left. So here I'm going to have plus pi over 3 for the coefficient c, which also will give us a phase shift of negative pi over 3. Graph this, and there you can see it's shifted to the left by that pi over 3. Again, that pi over 3 is not necessarily readily read off from the coefficient c, but would have to be divided by the coefficient b, which in this case is a 1. Okay, so that's one of them. The other one would then be that we again have a normal cosine. There it is. And now we change the equation, the second one, to cosine x minus pi over 3, and that should shift it to the right. And again, there it is. And I like to put the formula in and actually take a screenshot of it so I can insert it in my script. Okay, so that's what we saw here. The continuous curve is or the bold curve, I guess I should call it. The bold curve is the original cosine x, while the dashed curve denotes the shifted graph. And then what I said about the phase shift, that the coefficient c equals positive pi over 3 will yield a negative phase shift to the left, and minus pi over 3 will yield a positive phase shift to the right. And that's because of the formula for the phase shift. This is not in the next section, but actually see 2 sections down the road from this one here. I'm going to stop myself here and we'll tag on the remaining problems in the next recording. Welcome back to this problem session for vertical translation and phase shift. And the next few problems here are going to say, for each equation, identify the amplitude, period, and phase shift. Then label the axes accordingly and sketch one complete cycle of the curve. These equations are these here: y equals sine pi x minus pi over 2, then this one, and the fourth one is just slightly off the screen. Because they all have an amplitude of 1 or 2, I just leave the y-axis between negative 2 and 2. Okay, so here we're going to go the first one. Y equals sine pi x minus pi over 2. There is no vertical shift. The amplitude is 1. The coefficient b is pi. Because of that, the period comes out to 2 pi over pi, which is 2. The coefficient c is negative pi over 2. That being divided by the coefficient b of pi is 1/2. And then that negative is being canceled with the negative from the phase shift formula. So we're going to come up with phase shift equals 0.5. Okay. And then because of that, I'm going to say, well, our window is going to start at 0, so we can include the x-axis. It should actually start at 0.5, but I want to show the y-axis, but I want to show the y-axis. And then the largest value for x is going to be that phase shift plus the period, so that's why it's going to end at 2.5. I will also go ahead and graph the second one right away. So it's going to be y equals negative cosine 2x plus pi over 2. No vertical shift. Amplitude is 1, but notice it's reflected about the x-axis. Coefficient b is 2, therefore period equals 2 pi over 2, which is pi. and we have a coefficient of pi over 2, which divided by the 2 here is pi over 4, and then a negative from the phase shift formula will give us a phase shift of negative pi over 4. And the window will go from that negative pi over 4 to the phase shift plus 1 period, so to 3 pi over 4. So let's do these two on the graphic calculator. Okay. So the first one said y equals sine pi x minus pi over 2. There we go. I'm going to go to window, and I'm going to go negative 2 and 2 is the y min, y max. That's fine. And here I wanted to start from 0, just so I can include the y-axis, to 2.5 with a scale of 0.5. And there it is. It actually starts at 0.5. I'm going to show it in just a moment here. So it actually starts over here at x equals 0.5 right there. So that would be one complete cycle of this sine curve. Okay, the next one is going to be negative cosine 2x plus pi over 2. And I graphed that one respectively to window settings, and I said I would go from negative pi over 4 to 3 pi over 4. With a scale of pi over 6. And that one, because of the plus pi over 2, is actually shifted to the left by pi over 4. So it actually starts, let's see if I can show this. This might take a moment. Actually starts over here. And then because it has a negative in front of the amplitude, it's an upside down cosine that's reflected about the x-axis. This cosine shifted to the left and squeezed by a factor 2 to a period of just pi. Remember that the scale here is pi over 6, so we start here at, I believe, negative pi over 4, and then we end up here at 1, 2, 3, 4 pi over 6 respectively, 5 pi over 6 or something like that, 3 pi over 4, I believe is the last one. Okay, let's do the other two, and I'm just going to read them off my script here so I don't have to go forth and back to Word. It's pretty much the same deal here, so it's going to be a negative cosine 2x, I guess I could have just left that in there, 2x minus pi over 2 and because I start this later here, again I'm going to start, instead of starting at pi over 4, I'm going to start at 0 so I get the y-axis in there, and then I'm going to go to, let's see, 5 pi over 4. 5 pi over 4, and this is how it graphs. Again, it's an upside down cosine. The cosine itself starts right here. It's pretty close. And again, it's an upside down cosine because of the negative in front of it, in front of the amplitude of 1. And the last one says 2 sine 1/2 x plus pi over 2. Okay. And the window setting this time around, because here we have a total phase shift actually of negative pi. Let me go back here. So here the pi over 2 would be divided by 0.5, divided by 1/2, or multiplied by 2. So you're going to come up with pi, and then you have to put that negative in front of it from the formula. So negative pi, so the whole thing is shifted. Negative pi to the left. The period is going to be 4 pi, because the formula says 2 pi divided by b, so 2 pi divided by 1/2 comes out to 4 pi. So keep that in mind. I'm going to start at negative pi. And now the period is a total of 4 pi, so I'm going to go all the way up to, I add 4 pi to that, which comes out to 3 pi. And I guess the scale is going to be really small with the pi over 6. That's okay. And there it is. Let's go to the next, and I believe last problem. Okay, so this is what we graphed here all the way through. This was the last two, I guess, that I did on a graphing calculator. So let's do the last problem here. First of which says y equals -1 plus sine 2x plus pi. So we have a vertical shift of -1. We have an amplitude of 1. Coefficient b is 2. Therefore, the period comes out to pi. Coefficient c is pi, and therefore the phase shift comes out to -pi over 2, because we have pi divided by 2, put a negative in front of it, so -pi over 2. Therefore, the sine graph is shifted down by 1, then shifted left by pi over 2, and the window is chosen as -pi over 2, which is the phase shift, to the phase shift plus 1 period. And then for the y, I'm going to choose -1 plus -1, which is the vertical shift plus minus the amplitude. So, oops, not negative k, actually it's just k plus minus a. Okay, and the last one here is going to be y equals -3 plus sine pi x plus pi over 2, so vertical shift is -3, amplitude again is 1, coefficient b is pi, that pi is being divided into 2 pi, which means the period is going to be 2. Coefficient c is pi over 2, which is divided by pi, which is 1/2, and the negative put in front of it comes out to a phase shift of -0.5, so it's being shifted to the left by 0.5, and then the window is set to -0.5 plus 2. And because the whole graph is shifted down by 3, I would have to look at that. We end up for -3 minus 1, which is -4, and -3 plus 1, which is -2. So over to the graphing calculator and graph these two. So the first of these two is -1 plus sine 2x plus pi. There we go, and the window settings should be, let me look at that again. The x should start at -pi over 2, which is the phase shift. So -pi over 2, and then I add the period of pi to it. So I'm going to end up actually with pi over 2 on the right hand side. Notice it's pi in between, which is exactly 1 period for this one. And the x minimum, yeah, -2 is fine. And here I can go to 1 perhaps on the y-max, so I can include the x-axis. And then we graph. And there's exactly 1 period. Okay, y equals, which is going to be -3 plus sine pi x plus pi over 2. And here for the window setting, I would have to look at that. I have a phase shift of -0.5, so -0.5. Then the period is 2, as 2 pi is divided by the factor b of pi, b being pi, so 2 pi over pi is 2, so add 2 to that. I guess my scale here could change to 0.5. And the y minimum is going to be -3 plus minus 1 apparently, so I have to make sure that I have a -4 here. And here again I want to have the x-axis, so I'm going to put a 1 there. And we graph, and there it is. And again, exactly 1 period. And with that one, I am finished with this problem section for vertical translation and phase shift.